So let's take this right down. In long-range shooting, mountain hunting conditions are the toughest in the world. You've got some terrain effects, you've got lighting change, you've got some extreme heating and cooling that are going to cause the most difficult wind conditions that you'll experience anywhere. In addition to wind, you're also going to see some dramatic changes in elevation, which causes pressure change and air density changes, along with your temperature change of the air. You need to have some tools and some techniques that will allow you to compensate for those changes so you can make that shot when it presents itself. Now, the first of these is incline. Let's take a quick look at incline. Up in the mountains, you shoot uphill or downhill. We're pretty comfortable with the fact we need to make a change, but you might not realize that that change is the same whether you're shooting uphill or downhill. We need to aim low for either case. Essentially what we're doing is shooting for a shorter equivalent horizontal distance than that actual line of sight distance. And again, the effect is the same for up or downhill shooting. Let's take a look at an example. 700 yards with our typical long-range cartridge. We're talking 20-degree incline is going to give us a point of impact difference from horizontal that's about a minute of angle. That's 7 inches. So that's enough that we need to be aware of it, and we need to make a compensation. Now, if we take that same distance, that 700 yards, we put it on a 40-degree incline, now that point of impact change is more like 20 inches, which is huge. 20 inches of miss on even the biggest elk. So we do need to have the tools and equipment and the understanding to correct for an incline shot. But I think maybe more important than correcting for incline shots is correcting for air densities. Now, what I mean by air density is the pressure and the temperature of the air. So I speak in air pressure in terms of feet of elevation. Now, the thing about elevation and temperature is you're going to see changes from your shooting back home when you come out and hunt in the mountains. You're going to see a change. It's guaranteed it's going to be there. And on the hunt itself, you could potentially start at one elevation and end up hunting 2,000 or 3,000 feet different in the same day. Same thing with the air temperature. You're going to see a temperature in the morning that's way different than what you see after lunch. So we need to be able to compensate for those changes. Now, let's take a look at a case. You're set up back home, you're 2,000 feet, 50 degrees. Now, we've got a ballistic coefficient of 600, 0.60, and a muzzle velocity of 3,000. That's an approximate long-range hunting cartridge. Take that situation, put it in that 2,000 feet and 50 degrees condition, calculate it using an online ballistics program like G7, and you're going to see that your drop at 1,000 yards is 22.9 minutes of angle. Now that's about 240 inches if you care to get a feeling as far as how many inches that goes. 240 inches of correction. To compare that to mountain hunting, let's say Colorado elk hunt, early season rifle, we're going to start the hunt at 8,000 feet. And we're going to run about 70 degrees. So take that same BC, that 600, with the 3,000 feet per second, and calculate the scenario for 8,000 feet of elevation and 70 degrees. Now we're only talking about 20.3 minutes of angle. That's a big difference. We're talking 212 inches, that's 30 inches of point of impact change for, just 6,000 feet of elevation change. You also need to be aware of how the wind is affected, and your wind calculation can change based on those conditions. Just for that simple case of 2,000 feet elevation versus 8,000 feet, we're looking at 1,000 yards with a 10-mile-an-hour wind. We're talking 5.7 minutes of angle or 4.1 minutes of angle. That's essentially about 16, 17 inches of point of impact change just from that small change in air density. So if you've got a ballistics chart on your stock, or you've got a win number marked on your turret, you have to realize that that number is not going to be correct when your conditions change. What we need to do is calculate the actual amount in the field, or have multiple charts or multiple turrets, and that's just more gear that you have to carry up on the mountain. You can take all this gear and all this equipment and combine it and get a little simpler method by using the G7 BR2. Basically, with this device, what we've done is we've combined the angle cosine indicator that measures our angle. We've combined the ballistic computer that takes your ballistic inputs for your bullet and your muzzle velocity and calculates a solution. We've combined the weather station that measures your pressure and your temperature. We've put all those devices into this rangefinder so that you, in the use of the device, just press one button and it calculates that range and calculates your ballistic solution and tells you what to compensate so that you can make a really fast compensation in a hunting situation. Now, we've already talked about how significant changes in air density and incline are in tough mountain conditions. When you're shooting in the mountains, you're going to see those changes. You need to be able to make those corrections. Now, let's talk about some of the gear that you would use to do that. I've got one of our Gunwerks LR1000 systems. Now, with this system, I'm set up to shoot, one of our cartridges like the 7 Remington mag or our new 7mm long range mag. We take this system, custom action, our long range hunting stock, we put it together with the Night Force scope in our G7 configuration. Now, this G7 scope has the custom ballistic turret. Now, this is kind of the significant thing. We shoot the gun, we break it in, we develop a ballistic profile with the ammo in this gun, and then we calibrate this custom ballistic turret. Now, a ballistic profile essentially describes the shape of the trajectory of the cartridge. Now, every gun ammo combination is going to be different. And on the turret, we calculate the true BC and true muzzle velocity for that combination, and we mark these turrets with a ballistic calibration that's pretty easy to use. Let me explain it. Essentially, when you have a shot to a target, you're going to calculate the range and you're going to calculate the angle that you need to elevate your gun to correct for that shot distance. Now, this scope right here, this ballistic turret, has 0 to 20 minutes on the bottom that gives you that standard MOA correction. But the ballistic turret adds a secondary compensation. This takes that chart that we calculate and marks it on the turret. So these secondary numbers actually represent the yards or the distance to your target. So let's say you want to shoot 600 yards, you're just going to dial that turret to 600. Now, that means that we've dialed the correct amount of angle correction for that distance so that the bullet impacts vertically right on the bullseye. What we need to understand is, like, our ballistic turrets are built for a specific elevation and temperature. This one is 1,000 feet of elevation and 55 degrees of temperature. This turret assumes also that you're shooting horizontally. Now, if you make any changes to that, any deviation in elevation, temperature, or shot angle, you're shooting up or downhill, this turret and the turret data is no longer as precise as it needs to be to take a long-range shot. Now, with a BDC turret, what we really want to do is know how far to shoot for in kind of a corrected range. So if we have a device that will calculate and output and tell us that equivalent range or ballistic range or shoot to range, so to speak, that's what we want to have so that we can dial it to the turret. For example, I take the G7 ballistic rangefinder and I range 700 yards line of sight. Now, I could go through some math and do some calculations on a chart and look up a couple tables and understand that for these conditions, with this elevation and with this shot angle, I need to dial 650 yards. That would be our shoot to range. That's what we've made the G7 output. That's the standard BDC output. You program the BC, muzzle velocity, altitude, and temperature into the device. And then when you press the button, it tells you line of sight 700 yards, but then it comes back and displays the shoot to range, which is 650 yards. Now, the next thing that we need to do is take a look at how simple the G7 BR2 rangefinder is to program for your exact ballistic parameters. This is the G7 ballistic rangefinder, and I'm going to show you how to program a ballistic profile into the device so the device can calculate your exact ballistic solution. I've got this setup built so that we've got our G7 BR2 rangefinder mounted on this plate with a small HD camera mounted behind, and I'm recording what you would actually see in the device. So I'm going to be able to look at the LCD panel and press the buttons and show you step by step how to program and how to adjust these things. Now, the first thing that we're going to do is wake the device up by pressing the fire button. And then you can see in the top right hand corner it indicates that we're on profile number 3. So we're going to access the programming menu by pressing and holding the mode button for 5 seconds. Now in that programming menu there's 3 options. We got crosshair, we got backlight, and then we have the profile selection. So I'm going to select the profile selection for editing by pressing the fire button once, and I can scroll through the different profiles that are already programmed, which are profile number 1, 7mm, 2 is a 6.5, 3 is a 6XC, and I've got a 7 rem on 4. Profile 5's empty. So to program this profile, I need to select it for editing, and then I'm going to review by scrolling through the different items. So MOA, drag standard, ballistic coefficient, muzzle velocity, sight height, and zero range. Now if we change the drop unit to BDC, we'll see we have 2 extra inputs for altitude and temperature when we're using a BDC turret. So let's start by programming the drop unit. To select this item for editing and put it in the edit stage, I hit the fire button, and then to adjust the item I use my scroll button. I'm going to scroll up. I can do inches, BDC, or MOA. Now MOA outputs your MOA correction. BDC outputs a shoot-to range. That's your equivalent range, so 700 yards or 650 shoot-to for conditions. So I'm going to adjust this to BDC, and to save that I hit the mode button. That steps us back up to the ballistic menu. So let's go the drag standard. Almost all of our bullets are referenced to the G7 or G1 standard drag model. If we want, we can adjust that to the G7. I'm going to recommend use G1 unless you're in the know and you've already calculated your ballistic parameters using a G7. Now the ballistic coefficient is going to be either a G1 or a G7. Almost all manufacturers are referencing the G1. So to adjust that item, I'm going to select it for editing by pressing fire. Now you can see that one of the digits is flashing. That means I can adjust it by using my scroll buttons. Let's program a 617. So there's 6. The fire button also advances to the next item and scroll up 1 and then fire, and I'm going to scroll down 3. Now once you've got your ballistic coefficient programmed, to store that entry, I press the mode button once. That stores that entry and returns us up to that ballistic input menu. And then I'm going to use my arrow buttons to advance to the next item, which is muzzle velocity. Now to select the muzzle velocity for editing, I hit the fire button. Then we scroll up. Let's do 3,000 feet per second. Store it by pressing the mode button. Go to the next one, sight height. I'm going to use 1.7. So now I'm flashing on 1. I don't want to adjust that, so I just hit fire button to advance. Scroll up 2 to 1.7 and mode button to save. Now sight height's done. I'm back at that main menu. Let's go turret temperature. I've got a 5,050 degree turret, so I want to select that for editing. Scroll down 1 and then store it by pressing mode, advance to the next one, select it for editing. 5,000 feet. And if you, let's say you make a mistake and you want to go back, you just fire button, go all the way back around and adjust it to where you want it, and then store that by pressing the mode button. Now the last thing that we need to program is the zero range. Select that one for editing by pressing fire, scroll up to 200 yards, save it with mode. Now if we review, we've got zero range 200, turret altitude 5,000, turret temp 50, sight height is 1.7, muzzle velocity is 3,000 feet per second, ballistic coefficient is 0.617, the drag standard is G1, and the drop unit is in BDC. That'll output a shoot-to range. Now to save this profile, we're going to hit the mode button once. That'll return us up to profile 5, and then the mode button one more time. It takes 14 seconds to calculate that ballistic profile. build the tables that I need, and then when I go to use the range finding device, I'll press the fire button. It'll measure pressure, it'll measure temperature, side angle, and line of sight distance, and make a real ballistic calculation based on this program table. So it's done calculating. I'm at profile selection, which, if you remember, is our main programming menu. So I got the crosshair, the backlight, and the profile. Now, I need to go back to that fire main display so that I can take a range. I'm going to press mode one more time. Now I'm at the main display. You can see in the top right hand corner we're at P5, so I know that I've got my profile I just programmed. Now next up, we're going to use the G7 BR2 rangefinder to take a few shots up here in these mountain hunting conditions. All right, to close our demonstration on shooting and compensating for mountain conditions, we're going to use the LR1000 rifle from Gunwerks. This one's chambered in the old 7 Remington mag, not our new 7mm LRM. So our muzzle velocity is 30-25 and our ballistic coefficient is 617. This turret is built for 1,000-foot elevation and 55 degrees temperature. So we're going to set up the rangefinder at 1,000-foot 55 in BDC mode. BDC will give us a shoot-to range, and then we're going to use the ballistic turret to dial the range, that shoot-to range, to the target. So let me get this set up, get the rangefinder up. I programmed this back at the shop. It took me about 2 minutes, so it's ready to go. Now, I've got a cliff that's sticking out on the left here, real close to where this rock's at, so I want to shoot past all this obstruction in the front and get just the range to that rock on the back. I'm going to put this in farthest target mode, pressing the mode button. Now it took about 3 seconds to calculate that data. It was 1198 to the rock, and it says my ballistic range is 1109. So what I'm going to do is dial my turret here. I'm at 200. If I dial it all the way around in 20 minutes, it only gets me to about 925, about 930 yards. So I'm going to keep dialing up on the second row of elevation correction. I'm at 1,000 right there, 1,050 and 11. Now I'd be at 1,200 without the correction, but the rangefinder measured the pressure and the temperature here, which is about 6,000 feet, probably about 80 or 90 degrees. So it tells me I need to dial that down actually to 1109, which is, man, that's about 1, 2, 3, that's 4 minutes. That's about 5 feet, 4.5 minutes, just almost 5 feet at that range. So it's important to make that correction or else you're not going to hit. Now, while I'm at this in the rangefinder, it's going to calculate the perfect wind correction for that distance. We're going to be at 1198. And then it's going to give me that 1109, and then I just access the wind value right here on the side. It says for a 10-mile-an-hour wind at this elevation, I need 5.5 minutes. And if I scroll down to like a 5-mile-an-hour wind, it'd be half that. It'd be 2.7. And again, I could scroll up or down to 15 or 20. So 2.7 minutes for a 5-mile-an-hour wind at this distance. So I've got my data down. If I was doing a shooting test or routine, I might make a couple notes there. But I'm just going to demonstrate how this works. Let's see how that shot hits. Ear protection, eye protection, and get set up on the gun. Now I'm going to use my scope magnification. I'm going to see if I can pick up some mirage. Right here, running my Kestrel. You know, we're running about 2.5 to 3 mile an hour left to right. See what my mirage says out here. I'm showing some left to right mirage down there. So my wind's pretty consistent, left to right, about 3 mile an hour, you know, maybe up to 4. I'm shooting through this canyon, kind of looking at this terrain. I think it's probably reduced in the middle. So what I'm gonna do is I'm gonna correct for about a 2.5 mile an hour wind. It was about 3 minutes for 5, so I'm gonna hold 1.5 minutes to the left to correct for that wind. I think I only need one shot here. All right, that's 1,198 yards. Called my shot, just about a half minute to the right and about a quarter minute low. So pretty close on the wind dope. I don't know if you noticed the dust down there. We did have just a little bit of dust moving right to left instead of my left to right wind call, but overall that was a pretty good wind call for that distance. Now with the G7 BR2, I ranged it. It said 1198 for the distance. It told me to correct to 1,109 yards, and then it told me for a 5-mile-an-hour wind I needed 2.7 minutes. So I held about 1.5 minutes at 1,109 yards to hit within a half minute at 1,200 yards. Now, it's very simple to use, it's easy to program. For more information about the G7 BR2 ballistic rangefinder, check out the website at www.g7.com. We also have the G7 ballistic calculator there, so you can calculate your own drop charts and print them off. Those are free to use. Just sign up for an account and you can store your information there anytime. Join us for another episode here at Long Range Pursuit. Next week we'll have some more great hunting and some awesome shooting tips.
Hunting apparel for long-range pursuit provided by Sitka and Kinatrek Boots of Montana. License applications made through Cabela's Tags. Brought to you by Gunwerks, G7 Optics, Night Force, Hornady, and Caldwell Shooting Supplies.